So first technique we want to master is differentiating from your P logistic curve. These are logistic curves, right? Logistic curves. They will always look the same. So they don't change. Right? They've got to look, give or take, like those two. So P is like that, DP on DT is like that. Clear? So you know that this is logistic curves, not what you guys called it last week, rates of change. Even though it is a rate of change, it's very specific rate of change. It's called a logistic curve. Okay. Does anyone remember the logic of getting from P and then differentiating into DP on DT? What my first step should be? Something should be the subject from the P side. So we want to, yeah, the E needed to be the subject. That's the trick to it. So when you're going from this to this, make 3E negative T over 3 the subject, which is 21,000 over P, take away 7. Are we all okay with that? I've multiplied it, I brought the P back, and I took away 7. Now we differentiate. Okay, what's the derivative of the left-hand side? Well, 3 times negative a third, and then e to the power of t over 3 times dt on dp. Please be careful. It's not dp on dt because my left-hand side is now t. Are we okay with that? And then obviously to differentiate the p that's at the bottom, we can't do that. You bring it up as p to the negative 1. So that becomes negative 21,000 p to the negative 2. And then obviously 7 disappears. I'll pause. I'll wait for any questions. Are there any questions? Nope. All right, now we fix it up. Obviously, we didn't want dt on dp. We wanted the other way around, so I'm going to flip everything. So hold on. We're going to cancel this out. We're going to cancel this out. Happy? Then we're going to flip. If I flip, it'll look like this. dp on dt, and then the e, negative t over 3 goes at the bottom. Don't change that power to a positive power. So don't do that because you're not going to get very far with that. So you leave it as a negative. Okay, so that one, you leave them as negatives. If you're asking why you leave them as negatives, eventually we're going to substitute because we want everything in p's. We're going to substitute and we already have it as a negative. We don't have it as a positive here. So don't change this, leave it as a negative. All right, continue. Equals, remember we're flipping this, so that would have technically been over p squared, which means p squared goes on top, 21,000 goes at the bottom. So happy with that? At this stage, you multiply your e over. So dp on dt equals p squared on 21,000 times e negative t over 3, which you have made the subject, give or take. Obviously, there's a 3 there. All right. So it's going to be looking like this. Equals p squared on 21,000 times 21,000 on 3p minus 7 on 3. Because this guy, I might just put it in green, this guy equals 21,000 over 3p minus 7 over 3. True? As always, whenever I'm proving something, I don't continue. I look back at what I'm actually trying to prove because that usually tells me the answer. 1/3, 1 minus p over 3,000 p. Okay, let me have a look at this. Yeah, I kind of see it. All right, so again, I'll write it on the side. So I said 1/3, 1 minus p over, did it say 3,000? Yep, p over 3,000 times by p at the end, but that p at the end can just go at the front there. That's a little bit smarter. All right, we're going to expand this, right, you guys? So what's p squared over 21,000 times 21,000 over 3p? Well, the 21s would cancel, squared and p would cancel. I'm left with p over 3 minus, that becomes 7p squared over 3 times 21, which is 62,000. No, 63,000. Something wasn't working in my head. 63,000. And then what's 7 over 63,000? 7 over 63 is 9,000. I'm doing this slower than I would usually do it. And then you would factorize p over 3 and you're done. What I'm saying is you obviously are going to get it. So just take your time with it. That's what you wanted, and that's what we got. I'll stop the recording there. Any questions?